Hello everyone. Today we are going to see medical images obtained with ionizing radiation. First, we must understand what ionizing radiation means. Ionizing radiation is high energy radiation that has energy to remove electrons from atoms. That means it can actually change the atomic structure. The equation is given as energy is hv. So the frequency increases, the energy increases. That is why X-ray, gamma rays are ionizing because they have very high frequency and energy. Simple understanding. Normal light cannot affect atoms, but X-rays can disturb the atoms. That is why we say ionizing radiation can interact strongly with the matter. Now the question is, if it is dangerous, why do we use it? Because it has powerful advantages. Deep penetration. X-ray can pass through the body and it can detect dense structures, especially bones, and high information content. But there is a problem. Radiation causes biological damage. So very important idea is power comes with a biological cost. That's why we always balance image quality and the radiation dose. This is very important example. Now we come to the core physics. When X-ray enters the body, two main interactions happen. Photoelectric effect, photon is fully absorbed and the dominant in bones. And Compton scattering, photon loses energy and changes direction, happen in soft tissues. These interaction called attenuation. So the equation is I equal to I naught e power minus mu s. And here, this means X-ray travels through the intensity decreases depends on the mu. That was attenuation coefficients. The key idea is image contrast comes from difference in attenuation. If all tissues attenuate equally, there is no image. Now let us understand what does mu depends on. Mu depends on the density atomic number. So the bone have the high density. So it have the high mu. It absorbs mu, so it appears white in color. Soft tissues have the low mu value. So it is appears gray. So the important concept is contrast. It is the difference in mu values. Example is if everything had same intensity, full black images produced. If no diagnosis can be done, so the difference create the visibility. X-ray imaging is a projection imaging. Again, the same equation. I equal to I naught e power minus mu x. Here, X-ray pass through the body and form an image on detector. But here is the problem. It gives the 2D image. That means more structures are superimposed. Example, chest X-ray, ribs, lungs overlap. So the depth information is lost. Because of superposition, structures overlap, the soft tissues contrast is poor. So the doctors face ambiguity in diagnosis. Example, tumor hidden behind the bone may not be visible. So what we do is use advanced imaging like CT, MRI like that. The one modality, this one modality is not enough for all imaging. The limitations of X-ray is it has overlapping structures, low soft tissue contrast, and ambiguity in diagnosis. So it requires complementary modalities for clarification. CT, next one is CT, computer tomography. It solves the X-ray problem. Instead of one projection, it takes multiple projections from the different angles. Mathematically, P of theta s equal to integral of f of x y into ds. This is called a radon transform. The reconstruction is done. The tomography is the slicing of images. So no overlap. Each slice shows extract structure. That is why CT much clearer than the X-ray. Now, how does CT form an image? Uh, First, it collects the projections and apply filter and back propagation done, then get the final image. This uses Fourier transform and inverse random transform. The important idea is CT images is mathematically reconstructed, not directly captured. That's why powerful computers are required. Now we move to a different concept, nuclear imaging. Here we introduce a radioactive tracer inside the body. Instead of sending energy from outside, energy comes from inside the body. That shows the metabolic activity. And example is cancer cells consume more glucose. So the tracer accumulates there. The key idea is functional imaging. It is the functional imaging, not the structural. The next one is positron emitter tomography. The positron emitter tomography reacts with electron. Positive electron combined with a negative electron, it produces two gamma rays. This gamma rays photons have the 511 kilo electric volt in energy in opposite direction. Detector captures both simultaneously. This is called coincidence detection. So we can locate where the reaction happens. From this, PET maps activity inside the body. SPECT is similar but simpler. It emits single photon using rotating gamma camera, and it compared to PT, it has the lower resolution, cheaper, more widely available. The key difference is PET have high accuracy. SPECT is more accessible. All imaging systems follow same pipeline. That where the f of xy is the object, h is the system, and n is the noise. It the source, interaction, and detector reconstruction. The all modalities follow same framework. Now compare. X-ray have the 2D projection, but CT is a slice-based projection. PET is the functional map. Important as X-ray and CT are used to structure imaging. PET and SPECT are functional imaging. Different physics, different information. So select depends on the clinical requirement. Radiation is harmful, so we follow ALARA principle as low as reasonably achievable. We must balance dose versus image quality. And safety methods we have to use, reduce exposure time, increase distance, use shielding, like that. So the optimization is critical. Let's summarize. High energy photons interact with the tissue, produce signal, reconstruct image. Final takeaway is CT is better detailed slicing image it produces. PET is the functional image we can get. X-ray is a simple but fast imaging modality. So these are the different types of ionizing radiation.